Imagine if there was a particular school subject you hated, but for some reason the government forced you to take an exam in it at the age of 16. And not only that, they made you take 3. Wouldn't it be amazing if there was a website that made the entire revision and preparation process so much easier? Does such a website actually exist?
Yes, and that website is the Physics and Maths Tutor. Welcome back to this video where today I'll be navigating you around this website, explaining the different parts and features and what they do, and ultimately how I use this website to achieve 3 grade 9s in all of my sciences. Okay, so here we have the homepage, and for GCSE Science, what you're going to want to do is go to the top where it says GCSEs and pick whichever science you want to be revising today. So for this example, I'm going to take physics. And as you can see, there's 2 sections to each science. You've got the papers and the revision. And let's start off with the revision section. Obviously, you're going to pick the exam board that applies to you. A great thing about this website is that it has literally every exam board. So for this example, I'm just going to stick with AQA. And now you can see that this section splits it down into the 2 papers and the topics on these 2 papers. I'm going to keep it really simple and go to the first topic of paper 1, which is energy. A great thing about how this website is stratified, how it's split up, is that it just makes it a lot more manageable. You can see what you need to revise for each paper, for each exam, and you can see what you need to know clearly. It also makes it really good for topic tests, so maybe not your actual GCSE, but little tests you do throughout the year, you can clearly just go through the content for that individual topic. And you can see here that there's 5 sections to each revision section for each topic. And those 5 sections are definitions, mind maps, summary notes, flashcards, and questions by topic. So let's start off by looking at the definitions. So simple enough, the definitions part is literally all the definitions you need to know for this topic for the exam. So for the energy ones, it's about a page and a half, about 15 definitions that you need to know, and you can use these to contribute to your revision cards that you make when revising. Alternatively, you could use these definitions to test your friends or get your friends or other people to test you when revising. Okay, so the next section of the revision section is the mind maps. This goes through the whole topic and splits it down into the definitions and corresponding equations. So for example, in the top right here, you can see you have the gravitational potential energy equation and definition. Something that may be useful about using these mind maps is that they can link different parts of the course together for you, which can maybe make things be a bit more clear in your head when revising. So for example, at the bottom here, you can see that the conservation of energy links to things like efficiency and wasted energy. To be honest, I didn't really use this section personally, but if you're more of a visual learner, this section may be very helpful, so give it a go. Swiftly moving on, we have the summary notes, and as it says in the tin, these basically summarise everything you need to know for that topic. So it gives the definitions, equations, explanations and examples for each subtopic in this big topic. So as you can see here, for the power section, it gives you the definition and then the 2 equations you need to know for power. Then it gives a brief explanation of what the equations means, and then at the bottom it gives you an example of why motor A would be more powerful than motor B in this case. And I mainly use this section to see any gaps in my knowledge. For example, if I was doing some past exam questions on energy and something came up that I hadn't seen before, it wasn't in my stash of revision cards, I'd maybe go to this section and see what I missed out and then see what I need to know. Because everything you need to know is on these few sheets of paper. Okay, the next section is the flashcards. And for this example, I'm going to use the flashcards 1.1, which is for energy changes in the system. So if I click on this, as you can see, you get different slides, and then if you go along the slides, you'll get a question, followed by the answer to that question. And then this pattern just kind of repeats itself until you do all the questions. The first question is, what is the equation for kinetic energy? And then give the SI units for each quantity. So obviously you'd answer this yourself, so kinetic energy is equal to half mv squared, where E, the SI unit is joules, M, the SI unit is kilograms, and for V, the SI unit is meters per second. And you kind of get the idea. It's just a way to test yourself and utilise active recall when revising. And this section may be useful if you've left your revision maybe a little bit too late and you don't have enough time to make your own set of revision cards for a topic or for the whole exam. You could use these and you'll still utilise your active recall. A key benefit is that these are very easy and accessible to use, although do be cautious because not everything is on these flashcards. And then the 5th and final section for the revision section are the exam questions by topic. So as you can see here, there are 9 different question papers, all containing exam questions which have been picked out from past exam papers about the topic of energy. And then these have been split down further. For example, you've got changes in energy, efficiency, etc, etc. So if I just click on the first exam question by topic link, you can see there's 6 pages here of questions all about changes in energy. And as you can see, this ranges from 1 mark tick box, 1 mark definition questions, to calculation questions, and even 4 mark explanation questions. And of course, each question paper is accompanied by the corresponding mark scheme. So maybe what you can do is do a question paper on a topic you're not that strong at for revision. You can then go through it and mark it yourself. And if there's anything you don't understand or doesn't quite make sense to you, you can either look it up in a textbook, ask a friend, or take it to your teacher for your next lesson, and I'm sure they'll be able to help you out. So yeah, that kind of summarises the revision section of Physics and Maths Tutor. Of course, I just did this for one topic in one science. This is the same format for all three sciences and for every topic in the sciences. Now moving on to the second section of the website, and that is the exam papers. So let's just stick with physics and AQA. You can see we go to physics papers and then we pick our exam board, and you can see we have a list of past exam papers and their corresponding mark schemes and video solutions and model answers. And I'm just going to pick paper 1. So the exam paper and the mark scheme, that's pretty self-explanatory. The exam paper is just the exam paper for that year, and the mark scheme is literally the mark scheme they use when marking that exam paper. So the next part is model answers, and kind of as it says on the tin, these are answers that would gain full marks for each question. However, these model answers differ from the mark scheme because they're usually easier to understand. As you can see, the person who writes the model answers underlines and highlights part of the question, and usually summarises what the question is asking in simpler terms, and then provides the answer that would achieve full marks for the relevant question. And I would recommend using these model answers as your next course of action if you've looked at the mark scheme and it still doesn't quite make sense. And then the last section for the exam paper section of the website are these video solutions. So if you've looked at both the mark scheme and the model answers, you're still confused, you're still stuck, then the video solutions are the place to go. They are really in-depth videos and they explain what each question is asking and what knowledge you need to draw upon to achieve the marks for that question. I mean, the fact that these videos are an hour and a half long shows how much detail they put into making these videos and how beneficial they really are. I'll just play a short clip now of them explaining a question and what the video solutions kind of entail.
The student's head is represented by the sphere in figure 2. The student is negatively charged. The arrows show part of the electric field around the student's head. Draw 3 more arrows on figure 2 to complete the electric field pattern. So, the first thing that we need to understand when drawing an electric field is that if the field around the object is the same, which we're assuming it is in this question, the lines need to be equally spaced out. If we drew them and they weren't equally spaced out, this would indicate that there is a change in the strength of the field. However, in this case, the field is the same all around the object. Therefore, to draw 3 more arrows, we want them to be equally spaced out around the body, like so, and so they're perpendicular. Then we need to think about what direction does the arrow go in. So when we're looking at electrical field patterns, what we're describing is what would the path of a positively charged particle be in this field. So we know that due to electrostatic attraction, negatively charged particles and objects are attracted to positive charged particles. So this particle would move towards the body. Therefore, we draw the arrows inwards, like so, pointing towards the body. Also, the fact that the line that is drawn at the top that they've already given us, the fact that that is pointing inwards does also indicate to us that the other 3 lines on the body will point inwards, but it's just really good to understand why this is.
And that kind of summarises this video. Thank you very much for watching. Please consider subscribing if you haven't done so already, and maybe check out some of these videos if they seem up your street. If not, no worries, see you next week.